Today I will present some animations relating to the structural issues of high-rise buildings. Between 2001 and 2004, during our work for Silverstein Properties on the World Trade Center property insurance trial, we had the opportunity to produce animated exhibits on a wide variety of subjects. In an earlier podcast, we presented some of the animated reconstructions of the aircraft impacts and building collapses. Today I will show you some of the animations we created to teach the jury about the mechanical structure and strength of the World Trade Center towers. This is more of a science and engineering lesson, but I think it's a great example of how 3D modeling and animation can be used to illustrate complex structures and concepts. This first sequence shows the structure of the core of one of the towers, all the way from the basement B6 level to the 110th floor. The core, which contained the building's 99 elevators, was formed of 47 massive vertical columns and their associated horizontal beams. The second major element of the towers was the dense array of perimeter columns. This animation starts again at the very bottom level of the towers, where a man and a truck are shown to give a sense of size to this huge structure. As we zoom up the tower, we see the addition of thousands of columns that form the perimeter tube that also ran all the way from the basement B6 level to the 110th floor. Each face of the building was 208 feet across and contained 59 closely spaced steel columns. The third sequence illustrates a key feature of the Twin Towers. The roof truss, or sometimes called the hat truss, was a crisscross array of trusses connecting the interior core to the perimeter tube. This structure proved to be a lifesaver on 9/11 by allowing the buildings to redistribute vertical loads and remain standing immediately after the aircraft impacts. The fourth sequence illustrates the floor system that also tied the perimeter tube to the core columns. Each concrete floor of the World Trade Center was an acre in size, most of which was open space, free of support columns, since this unique design placed the columns around the exterior. Fireproofing material was sprayed over all the exposed steel surfaces that made up the core, perimeter tube, and floor support trusses. This fireproofing was designed to protect the steel in the event of a typical office fire. And on 9/11, the fireproofing did its job in the places where it was not knocked off by the high-velocity debris from the impacting aircraft. This color-coded fireproofing tutorial animation was generated from calculations done by Hughes & Associates. The arrow next to the color-coded thermometer in the middle of the screen will track the increasing temperature in a room where a fire is growing. Temperatures were also color-coded from a room temperature 70 degree Fahrenheit blue to red hot at 1300 degrees Fahrenheit. The I-beam cross-section on the left is unprotected, while the one on the right has a thick layer of fireproofing. In this animation, the colors of the steel and fireproofing change as the temperature of the fire increases over time. The unprotected column on the left closely follows the temperature increase of the fire, while the protected column remains in the blue room temperature range, even when the fire and the outer surface of its fireproofing are at 1300 degrees. These animations played an important role in proving to the jury that the World Trade Center towers were strong, well-designed structures. This conclusion was an important stepping stone on the way to demonstrating that the collapse of each tower was an independent event.